All right, welcome back to another edition of Math in My Kitchen. Still working on area. Today we're going to be working on what are known as composite figures. Composite figures are just figures that are made up of more than one figure. For instance, we have this shape here. We need to find the area of it. There's no formula for the area of whatever this shape is, but we can cut it into shapes that we can do areas of. And then just add all of the pieces together and you get the area of the whole thing. You can cut this into any shapes that you want to, but I would recommend cutting it into ones that make it easiest. This one, obviously, we can make into a couple rectangles. I'm going to chop this into these two rectangles, rectangle 1 and rectangle 2. We can find the area of the 1, area of rectangle 2, add them together, we'll have the area of the whole thing. So, the area of rectangle 1 is just length times width, so 12 times 15, easy enough. Now the area of rectangle 2, we know this distance is 27. How do we get this distance? Well, we do know from here to here is 21. But we only need this piece of it. So if we happen to know how long this is, we could subtract that from 21 and that would leave this. Well, they were kind enough to tell us that that is 12. So this is just 21 minus 12. So that is 9. And then you just do this times this times this, add the two things together, and you will arrive at the area, which the book claims is 423. I'll be honest, I didn't do the math, so I don't know if they're right or not. I'm going to take their word for it. But not all figures are going to be quite as easy. So we have this thing. And they would like for us to find the area of this. Well, we can't cut it into rectangles, but we can cut it into this triangle, this rectangle, and then this semicircle. So we've got this thing up here, this thing in the middle, and this thing here. But there's more work to be done before we can figure that out. Because triangle, you have to do 1/2 base times height. Well, we don't know the base. Rectangle, length times width. Well, we don't know the width in this case. And semicircle, pi r squared divided by 2, we don't know r either. So we need to figure out how long that is. And to do that, we need to go back to our favorite dead Greek guy, Pythagoras, because this is a right triangle. So we can do a squared plus b squared equals c squared. So we're looking for this. So we're going to say x squared plus 7.8 squared is equal to 10.2 squared. So x squared is equal to this minus that. So x is equal to the square root of this squared minus that squared. If you're wondering why these, all right, so I'd like to pretend that I did this on purpose and say I was doing this to see if you could see what I did wrong, but I didn't. I made this same mistake when I was preparing for this too. I did something wrong here. Any idea what it is? All right, so your eagle-eyed people will notice that I use 7.8. 7.8 is the distance from here to here. I don't need that distance. I need this distance. So how do I get that? I need to subtract that piece. That piece is 3, so this really should be 4.8. Now, if you're wondering why they gave you these weird numbers, you have to do weird numbers when you get triangles to get decent numbers. If you do this math, if you have a calculator on you, you will find out that this ends up being 81. So this is 9. So this distance here is 9. Now that also means this distance here is 9. We're going to need the radius, which is half of that. So the radius is 4.5. And now we can just do the area of this triangle, which is 1/2 base times, almost did it again, times height. There, the rectangle in the middle, which is length times width. And then the area of the semicircle, which is 1/2 pi 4.5 squared. Do the math, you will arrive at the answer, which is, again, the book claims is 80.4-ish. I didn't do the math again, so we're going to have to take their word for it. But easy enough, just cut it into figures that you can do the shapes of, do the areas of, and then just add all of the areas together. Now there is one more twist that they like to give you, and that is the area of shaded regions, where they will give you the shape. Let's say this is 18, this is 36. And they will say, find the area of the shaded region. All right, so to do the area of a shaded region, just do area of the whole thing, and then subtract the part that you don't want. So the area of the whole thing is just this rectangle. So 18 times 36, and then we have to subtract out this triangle. That's a 9. So area of the triangle is 1/2 base. Well, this base is the same as that base, times the height, which is that. And again, I'm just going to take their word for it. When you do the math, they got 486. All right, so your work for this section, page 697 through 17, and then also a reminder, I will be having office hours on Zoom from 10 to 11 every weekday. Just go to Zoom, go to join meeting, and my meeting ID number is this. And this will give you a chance to ask questions if you have questions, and I can go over them face to face instead of trying to do it through the little Q&A thing on the website. I miss seeing you. Hopefully we'll be back together soon. That's it for today.